Welcome back, students. In this video we will discuss about VI graphs. So far we have covered basics of how current flows, definition of voltage, current, how they are measured, the errors in the measuring device, electrical circuits, schematic diagrams, difference between conductors, insulators, resistors, how the resistors can be arranged in series parallel, and we have seen a couple of board exams as well as textbook problems around these topics. In the last video, we discussed about the Ohm's law and touched a bit upon the VI graph. In this video, we will delve more into the VI graph, which is very important because there are quite often questions repeated around the VI graph. So we will try to understand in depth the VI graph, the concepts, and in the next video, we'll try to solve a few problems. So in the last video, we saw VI graph is where the voltage is on the y-axis, current in the x-axis. The graph passes through the origin. The straight line indicates that the current and voltage are linearly proportional, or it is proportional, and the proportionality is because of the resistance. The value is the resistance. There's a constant slope. Wherever you measure delta I and delta V, you get the constant slope. Slope is nothing but y by x. Y is delta V and x is delta Y, which is V by I is nothing but resistance. So in the what I would suggest is you pick up a graph sheet and try to plot two graphs, two lines. One with a resistance R and another with a resistance 1 by 3. R is equal to 2 and R is equal to 1 by 3. That is 0.67. X-axis of the current, Y-axis is V. So I have given a sample set of data for resistance is equal to 2, V is equal to V by I. So I value of current, the value of voltage. Current is 123, voltage is 246 because they have a relationship of 2. Similarly, when it is 1 by 3, you should ideally take 3 values, but for simplification, I'm just taking 2 values. So the value of I would be 3 amperes, 6 amperes, and voltage is 1 and 2 volts. When I plot this in a graph, there is a lot of interpretations. As I said, 0 current, 0 voltage. So the graph starts at the origin. And when you are given a graph like this, the steep one, the high steep one is the line corresponding to high resistance, that is resistance value 2. A relatively flatter line is the one which corresponds to lower resistance, that is resistance is equal to 0.67, that is 1 by 3. Given a graph like this, you should be able to calculate the resistance. So how will you calculate the resistances? Based on the slope. So for example, here when I calculate the slope, delta V is 2 volts, okay, and delta I is 1 amperes. V by I is 2. So given a graph, you can calculate the resistance. Same way, here if you see the flatter line, delta V is 1 volt, whereas the current is 3 amperes. V by I is 1 by 3. That is exactly what we plotted the graph for. So please have in mind, when two graphs are given, the one with steep slope has a higher resistance and one with the low resistance has a flatter slope. So we all know that slope gives resistance. And one more inference what I would suggest is, now try to interpret or relate the voltage and current by seeing these dotted lines. There's a dotted line over here as well as there's a dotted line here for line B or the graph B. Similarly for A, you have a dotted line for voltage and dotted line for current. So looking at the dotted line, you should be able to make some inference. So what is that we will see? So line A, let me take line A. There is a less voltage change, but the current changes more. Means for the smallest change in voltage, there is a huge flow of current. So this reflects low resistance, path of low resistance. Now, when you take the line B, for such a big change in voltage, maybe 3 units or 4 units, whatever, the current increases by only 1 unit. More voltage change and less current change means B represents the circuit with high resistance. So how we will interpret the VI graph is steeper slope, stronger or higher resistance, flatter slope F you can relate like this F, and similarly S you can relate this way. Steeper slope, stronger resistance, flatter slope, free flowing current due to lower resistance. So there are a couple of scenarios which we will discuss in the next video, all that are very important and quite often repeated in the board exams. Bye and thank you till then.